Alright, in this video we're going to say if we're going to take quadratics and we're going to look at how it affect how the parent function we're going to affect the graph of a parent function f of x equals x squared when f of x is replaced by the following. So we're going to have like a few steps here. So first thing we want to know is what is a quadratic parent function. A quadratic parent function touches the origin, and it's usually a 1-to-1 ratio, so it's like on 1 over 1, basically. But it happens to do with it's not going to be like that, like a line where it is a 1-to-1. This one just starts off as a 1-to-1, and after the 1-to-1, then it breaks up. So there's a couple things you need to know. You need to know that y equals f of x and f of x squared. I'm sorry, y equals x squared and f of x equals x squared are the exact same thing. F of x is the exact same thing as y, and this is the parent function for the quadratic. Now, whatever they do to the x squared, alright, whatever they do to that, that's what's going to cause it to change. Alright, so in this first video, I have, in red, we have f of x plus b. So the number that is, alright, so this one right here, when the number is being added or subtracted to the f of x, or the function, the number of spaces, the points shifts up. So this one, it's going to shift up that many spaces. The green one, when it's negative, it's going to shift down in that many spaces. All right. All right. So let me give you an example. So let's take the red one first. We're going to say f of x plus 2. All right, so we're going to, since it's a plus 2, we're going to go up 2 units. All right, so like in the example, I'll go up 2 units. 1, 2, so it'll go up 2 units. That looks like this. All right, and that's what happens. In the green one, if we had f of x minus, let's say, 3, then it'll go down 3 units. All right, so I'd go 1, 2, 3, so it'll look something like this. And so that happens. So you gotta have to remember that whenever you're adding something to the parentheses, it goes up the y-axis. If you subtract, it goes down. All right, the next one we need to kind of look at is what happens when you're adding inside the parentheses. So remember the first one, and I'm just going to we had something like this where we were outside the parentheses. All right, these were the two that we just talked about on just the last slide. See how they're being added or subtracted outside the parentheses? These are inside the parentheses, so they're done differently. All right, so when they're outside, they go up or down. When they're inside, they go left to right. Now, when it's positive, all right, when it's positive, when we're adding, we move to the left. B spaces. All right, if it's negative, we're going to go to the right. B spaces. All right, so let me give you an example. Let's do this one right here. All right, so you see that I wrote f of x plus 3. Okay, so this means, since it's positive, see what we want to do is we'll make a 0 inside the parentheses. So what do I put in for x to make it 0? Minus 3. That's why we go to the left. So we're going to go to the left 3 units. Now we're talking about from the origin. So like right here, I'm at 0, 0, so I go 1, 2, 3. So that's my dot, and I'm just going to have it look like this. See how it moved to the left? All right, now the next one, we're going to put, so this is a plus 4, so what do I put in? Oh, I put plus 4. I want a minus 4. Sorry. We have x minus 4. So, okay, so this one's a minus 4, so what do I put in for x to make it 0? So I'm going to go to the right 4 units. So that means I'd go 1, 2, 3, 4. So it'd be right here, and so I would draw my parabola would shift in this direction. It would go that way. Don't forget that when you need to kind of compare it to the other one, when the parentheses, when it's outside the parentheses, you go up or down, right? When it's inside the parentheses, whether it's plus or minus, you go left or right, depending on that. Now we're going to talk about what happens when you have this situation. So here's our parent function. The a represents a number that we're going to multiply to f of x. So whenever you see the number outside the being multiplied to x, outside the parentheses, so let's say, let me give you an example. Let's say it looks like this. Like that, that means you're going to, this is what I mean by the a. If it looks like this, alright, that's what I mean by this a, just to kind of give you a heads up. Alright, so I'm going to kind of explain this a little quick and then we'll do an example. Alright, so on this one's the one where you have to watch. If it's greater than 1, if a is greater than 1, and I'm going to put the greater than symbol, I think you can figure that out. If a is greater than 1, then it's going to be, the graph is going to get narrow. It's going to get thinner. It's going to look like it's thinned up, okay? If a is a fraction or a decimal, that means it's between -1 and 1, it's going to be wider. The parabola is going to be wider. And that means the closer it is to 0, the wider it is. Alright, so again we're going to be playing with the compress and stretch thing. So when you're looking at a problem and you know that the a is greater than 1, you know it's going to get narrow. So you've got to figure out what you're going to do. When the a is on the outside like here, that's like the y, so that means vertical. So we're going to say that this is vertically, this is going to be vertical. Because the a is outside. Remember the y, it's like you're multiplying to a y and the y is on the outside. This one you're multiplying to the x, the a multiplied to the x, so this one is horizontal. If I could spell horizontal. Alright, so we have two different ones. We have compress, we have stretch. For both of them, compress and stretch. So let's think about this. Now remember, you got to focus on the number being greater than 1 or less than 1. So if it's compressed, that means think of the vertical axis. If we compress, that means we push down like this. It's going to be wider. If we stretch, it's going to be narrow. We're talking about the parabola. Alright, on the horizontal, if you compress the horizontal, it's going to be narrow. If you stretch it, it's going to be wider. We're talking about the parabola, the shape of the parabola. Alright, so here we go. Let's do an example. And then I think if we do an example, I think you'll kind of understand a little bit. And I'm going to leave, I think I'm going to leave these, I'm going to put this different color. We're going to say this one is vertical. I'm putting a different color so you can see it better. Now that's vertical. And then this one we're going to say is, this one, if I can get my pen to work, it's going to be horizontal. Alright, we just got to remember the other part. Alright, so let's say that we have an example. Let's go with, I'm just going to make something up, try to make something easy up. 3x plus 1 squared. We'll just do that. Alright, So the 3 is outside, so that means that it is bigger than 1. All right, and so because it's bigger than 1, we know it's going to be narrow. And then so if it's vertical, because it's outside, the 3 is outside. See it right here? It's the A actually is outside. And so we know it has to be vertical. All right, so we got to use the word vertical. So if it's getting narrow, what am I doing to the vertical axis to make it thinner? I'm stretching it. So we're going to say vertically stretched 3 by a factor of 3. All right. If this was a half, all right, and so like let me draw what that would look like too, so you can see it. And like I said, we're just sketching it, so it would look something like this. All right, let's do red on the other one so you can kind of see it. Let's say that we change this and we're going to make it 1/2. All right, 1/2 would make this, and I'll do it in another green, it would make it wider. So that means it would be something like this. That one would be wider because it would because the half, it's like making a thing. So you got to think, okay, if it's half, it's wider. So what am I doing to the vertical axis to make it wider? I'm compressing it. So otherwise I'm pushing down on it when I'm doing it. So when I'm compressing, I'm pushing it together, making the line like go in this direction. I'm forcing it down. Make sense? All right, and that's the way with the horizontal as well. Horizontal, if I had something that looks like this, that means it's getting bigger, narrower. All right, so I'm going to erase this so we can kind of redo this. So if it's greater than 1, if that A is greater than 1, that means that it's getting narrow. So here's my parent function, and my narrow would be like this again. And so what am I doing to the horizontal axis this time? Because remember, it's the A's inside. So horizontal means that I am compressing it to make it narrow, and I'm stretching it. So if I had a 1/2 x plus 1 here inside, that would stretch, and this one would compress.